Hey guys, so in this lesson, we're going to learn a new factoring skill. And in specific, we're going to learn how to factor different sorts of trinomials than the ones we've learned before. And to help refresh our memories, and because it's really helpful, what I'd first like us to do is multiply out these four products of binomials. Because the products that we get in each of these four cases are going to be the sorts of trinomials we want to learn how to factor. So multiplying these is going to be really helpful for us to realize how to factor them later. So in this first example, b plus 3 times b minus 6, I think if we were to multiply those together, well, b times b is b squared. b times negative 6 is negative 6b. Then we get a positive 3b. And 3 times negative 6 is negative 18. So I think our final product in this case would be b squared minus 3b minus 18. Okay, in our next example, a plus 5 times a plus 4, I think if we were to multiply those together, we would get an a squared plus a 4a plus 5a plus 20 for a grand total of a squared plus 9a plus 20. And I ask you, as we're making our way through these, if you can notice any patterns about the products and the two binomials from which they came. In our third example, x minus 6 times x minus 2, I think the product would be x squared minus 2x minus 6x. Negative 6 times negative 2 is positive 12. So x squared minus 8x plus 12. And last but not least, for m plus 12 times m plus 1, we would end up with m squared plus 1m. I'm even going to write the 1. Plus 12m plus 12. For a grand total of m squared plus 13m plus 12. And so what I want us to do is take a moment right now to look at these products that we got from each of these four multiplication problems. And these are the sorts of trinomials that we're going to be learning about factoring today. And so note that they all have a very specific form. They all start with just some variable squared. So b squared, a squared, x squared, m squared. Then they all have just some constant times that variable. So negative 3b plus 9a, negative 8x, positive 13m. And then, of course, they all end with a constant. Negative 18, positive 20, positive 12, positive 12 again. And you can see that all of these trinomials down here, too, which we're going to factor soon, all have that same general form. So I want us to take a moment to consider how we got here to think about how we can then take these trinomials and factor them. Well, the b squared, we know where that came from. B times b. The negative 18, we know exactly where that came from. That came from the last of the four multiplication steps for this, the 3 times negative 6. And this negative 3b, well, if we think about these two middle multiplication steps, we had a b times negative 6, so negative 6b, and a 3 times b, 3b, and the sum of these two was negative 3b. So these two constants, positive 3 and negative 6, their sum determine the coefficient on this middle term right here. Same thing with this example. The a squared, well, that came from a times a. The 20, that came from the last step, 5 times 4. And this 9a came from the middle two steps, 4 times a and 5 times a. And 4 plus 5 is 9. All right, here we go. We know where the x squared came from. We know where the positive 12 came from. The positive 12 came from negative 6 times negative 2. And this negative 8x came from those two middle steps. X times negative 2, negative 2x, and negative 6 times x right here. And so this coefficient again in the middle term was the sum of these two constants in the original two binomials. Same thing here. M squared came from m times m. 12 came from 12 times 1. And this 13m came from these two middle terms in the multiplication. And this 13, once again, was the sum of these two constants in the original two binomials. So in general, if we find a trinomial of this form, we know that it will factor as just that variable and a constant, that variable and a constant. Well, what are those constants going to be? They need to multiply to one another to give this final constant term out here. And when you sum them up, they need to give this coefficient of the middle term. And I think this will be a little bit more clear when we do a few examples. So let's get right to it. So our first example of a trinomial we want to factor is 10m plus 16 plus m squared. First things first, let's go ahead and put this in a standard form because that's definitely just best practice. So m squared plus 10m plus 16. Okay, so I notice immediately that we have a trinomial, and I notice that it's got just an m squared in front. It's got kind of a 1 as a coefficient. And that's actually really important about all these trinomials that we're factoring right now, that b squared and a squared and x squared and m squared all had a coefficient of 1 in front. So we often don't write the 1, but there's an implied 1 there. And if the coefficient on these squared terms was anything other than 1, this strategy wouldn't work. And also, if it was anything other than b squared or a squared, if it was to the third power or fourth power, this strategy also wouldn't work. It's got to be a very specific type of trinomial. But this one fits the bill. So we immediately know that this guy right here is going to factor as m plus something times m plus something. And we don't know what these two guys are going to be right now. But if you think about the multiplication, when we multiply these two together, of course, we're going to get m times m. That's going to be m squared. That's the easy part. And we know that this number times this number is going to have to be 16. So my next strategy is mentally, I think of all the factors of 16. Well, I think we've got 1 times 16. I think we've got 2 times 8. And I think we've got 4 times 4. Now note that these numbers can be both positive or negative. So it could be -1 times -16, -2 times -8, -4 times -4. So it's always good to keep that in mind, that you could have both positive or negative factors. Well, we need these two numbers to multiply to 16, but if we think about the middle two steps of when we multiply this out, we're going to have m times this number and another m times this number. And we need that to equal 10m. So these two numbers must add up to 10 and they must multiply to 16. And when I look over here, do I see any numbers that multiply to 16 and add to 10? Absolutely. 2 and 8. So I think that this polynomial right here is going to factor as m plus 2 times m plus 8. And you know what? I think it'd be a great idea to take a moment to actually multiply that out to confirm our factoring. So if we multiply this out, we'll get an m squared. Our second step, we'll get an 8m. We'll get a 2m. Oh, there goes our 10m right here. And our last step, 2 times 8, that gives us 16. And so indeed, we have successfully factored that polynomial using this new strategy. So let's do a couple more examples. In our second example, b squared plus 11b plus 10, it's already in standard form, no common factors. We see that it is a trinomial and it fits the form of these specific trinomials we're trying to factor. We got a 1b squared, 11b, and 10. Boom. We immediately determine that we can factor this as b plus something times b plus something. Again, we don't know what these two numbers are, but we do know that when we multiply them together, we're definitely going to have to get 10. And when we add these two together, we're going to need to get this coefficient right here, 11. So I'm thinking, are there any factors of 10 who will add to 11? Well, let's think of the factors of 10. I think the factors of 10 are 1 times 10 and 2 times 5. Of course, they could be both positive or both negative. 1 times 10 is looking pretty good because these two numbers multiply to give 10 and they add to give 11. Let's just confirm. If we were to multiply this out, we would get b squared plus 10b plus 1b plus 10. Oh, check it out. We would get b squared plus 11b plus 10. This is awesome. That is exactly what we were hoping. And so we have factored this correctly. And so hopefully we're starting to get in a bit of a groove here. All right, more examples. h squared minus 11h plus 24. This one's going to be a little different. Granted, it is in standard form, no common factors. It is in the type of form that we want our trinomial to be. So this is the specific type of trinomial we're going to factor using this strategy. So we know that this is going to be h plus some number times h plus some number. We don't know what these two numbers are yet. But we do know that they need to multiply to 24. Now, 24's got a lot more factors, but that's okay. The factors of 24, I'm thinking 1 times 24, I'm thinking 2 times 12, I'm thinking 3 times 8, and 4 times 6. Of course, they could be either both positive or both negative. So these two numbers are going to have to multiply to give positive 24, But when we add them together, they need to give negative 11. And so when I look over here, I'm thinking 3 and 8 are looking good because they multiply to 24 and add to 11. So that means if we did negative 3 and negative 8, they still multiply to 24, but they add to negative 11. So I think that this polynomial is going to factor as h plus negative 3 times h plus negative 8. Now, of course, that's a pretty awkward way to write it. So instead, I would write this as h minus 3 times h minus 8. And if we multiply this together, just to make sure, h squared minus 8h minus 3h plus 24. Let's see, h squared minus 11h plus 24. Looking good. We've successfully factored it. All right. Hopefully we see a pattern developing here, and maybe you can start anticipating how to factor these guys before we even make it through in this video. But let's continue. N squared minus 8n plus 16. Standard form, no common factors. This is that specific type of trinomial. Let's do this. So we know immediately that this is going to factor as n plus some number times n plus some other number. All right, these two numbers have to multiply to give positive 16, and they need to add together to give negative 8. And you know what? I think two numbers that multiply to give positive 16 but add to negative 8 will be negative 4 and negative 4. So I think that this polynomial is going to actually factor to be n minus 4 times n minus 4. And in fact, maybe you didn't notice already, but this also happens to be a perfect square trinomial, which we've discussed how to factor before. So this is not only one of these very nice trinomials that we like factoring in this lesson, but it also happens to be a perfect square trinomial. Very cool. All right, how about this guy? P squared minus 2p minus 24. All right, so this is in standard form, no common factors, and it is this specific type of trinomial. So we know this is going to factor as p plus some number and p plus some other number. All right, these two guys have to multiply to give negative 24. And so it's really important, if we're going to multiply these two and get negative 24, one of them's got to be positive, one of them's got to be negative. So immediately we keep that in our mind. And I'm going to even write out the factors again of 24. So 24, the numbers that multiply to give that are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Now, we know that one of these is going to have to be positive and one of them is going to have to be negative. And when we add them together, we've got to get negative 2. So which of these pairs of factors looks like it's going to fit the bill? I think 4 times 6 is. So I think if we had a negative 6 and positive 4, they would multiply to negative 24 and they would add to negative 2. Boom. I think we've got our factorization right here. So I think that that polynomial is going to factor as p plus 4 times p plus negative 6, or how we'd actually want to write it is just p plus 4 times p minus 6. And I leave it to you to multiply these together to confirm. Now note, eventually, I hope that we can look at these trinomials, figure out the factors we need, and just hop right from here, boom, to the final factorization. But if you want to write down these factors to help out, absolutely, be my guest. All right, I know it's a lot of examples, but I just want to do a few more. So g squared plus 10g minus 20, standard form, check. Common factors, don't see any of them. Is this in the form we want? 1g squared plus 10g minus 20? All right, it's looking like one of these trinomials. So we're thinking that it might factor as g plus some number times g plus some number. All right, now these two numbers, they're going to have to multiply to give negative 20, and they're going to have to add to give positive 10. Now I'm thinking about the factors of 20, and I've got 1 times 20, I've got 2 times 10, and 4 times 5, and we know since these are going to have to multiply to negative 20, one's going to have to be positive, one's going to have to be negative. And you know what? I don't think any of these pairs of factors are going to be able to both multiply to negative 20 and add to positive 10. So you know what? With the skill set we have right now, this is just not a polynomial we can factor right now. So we just kind of have to leave it as is, which is a little bit too bad, but hey, it happens. And, you know, just note to self, eventually maybe we'll be able to factor it. And you know how this guy actually factors? it actually factors as g plus 5 plus the square root of 45 times g plus 5 minus the square root of 45. So a seemingly benign trinomial actually has quite the factorization, but we'll save that for another class. So just wanted to let you know that even though we may have a trinomial of this nice form, doesn't always mean that it's going to factor. All right, just 3 more examples that I'd like us to explore. So I'm looking at this first one, negative 3h squared plus 3h plus 90, and the first thing that I notice is, oh, we've got this negative 3 times the h squared in front. So while this is a trinomial, right now, it doesn't look like these trinomials that we've been factoring because they all have a 1 times this variable squared. But if we look for a common factor, I'm seeing these coefficients of negative 3, 3, and 90. I think that 3 is a common factor of all of them, so maybe we can factor that out. And in fact, let's factor out a negative 3, so we can have a nice 1h squared in our remaining polynomial, which would be really fantastic. So let's rewrite this guy as negative 3 times the quantity of h squared, that's awesome, minus 1h, minus 30. And so it appears that inside of these parentheses, we've got a trinomial who's got a 1h squared minus 1h minus 30. This is one of these trinomials we've been trying to factor. Let's go ahead and try and factor it. So if we were to factor this out, we would end up with negative 3 times h plus some number, h plus some number. All right, let's figure that out. Well, these two numbers are going to have to multiply to give negative 30, meaning one's going to have to be positive, one's going to have to be negative. And these two numbers are going to have to add together to give negative 1. So we get this negative 1h. So I'm thinking that we should use negative 6 and positive 5. Those two numbers multiply to give negative 30 and add to give negative 1. So let's do h plus negative 6 times h plus 5, or as it would be a little bit more formally written, h minus 6 times h plus 5. And you know what? I feel like multiplying these together just to confirm. If we multiply those two together, we get h squared plus 5h minus 6h minus 30. We would get h squared minus h minus 30, which is exactly what we were trying to factor right here. And of course, this negative 3 would still be there, and if we multiply that by these guys, we would get our original trinomial. So this is right here, our final factorization of the original trinomial. So just always got to keep in mind that you might need to look for a common factor, which happens again in this example. Right? The first thing I notice is we've got a trinomial, but this negative 6 in front of m cubed. This is not one of those trinomials we've been looking at so far, but I think we can factor out an m from all 3 terms and a negative 6 from all 3 terms, and that's going to leave us with something much, much, much nicer. If we factor out a negative 6, we can write this as negative 6m times the quantity of m squared, that's awesome, minus 5m minus 50. Ooh. So now we've got one of those trinomials in the form that we like. We are going to look for factors of negative 50 who add to negative 5. And I think that negative 10 and positive 5 are the factors we're looking for. So I think that this guy right here is going to factor as m minus 10 times m plus 5. And of course, you always want to bring on down the common factor from before. And so this is our final factorization of that original trinomial. And I leave it to you to multiply out just to confirm. All right, one last example, and then we're done, I swear. Okay, here we go. 4a squared minus 20a plus 25. Okay, I'm thinking, all right, it's a trinomial. I do not see that we have a 1a squared. Maybe we can factor out a 4. We can factor out a 4 from here. We can factor out a 4 from here. But we can't factor out a 4 from there. So this is not going to be one of those nice trinomials that we've been doing this whole lesson. But that doesn't mean we can't factor it. Why? Because there's another skill that we have for factoring trinomials. Maybe this is a perfect square. So if this original strategy that we tried didn't work, let's see if this is a perfect square, in which case we can factor it. So let's look at 4a squared. Is that a perfect square? Absolutely. That's what you get when you take 2a and square it. Is 25 a perfect square? You're darn right. That's 5 squared. So we're thinking that if this guy is a perfect square trinomial, then it would factor as 2a plus 5 times 2a plus 5, or 2a minus 5 times 2a minus 5. This negative 20a is our middle coefficient, gives it away that it would indeed be 2a minus 5. And if we multiply these together, just to confirm, we would get a 4a squared minus 10a minus another 10a plus 25. Oh, we're looking good now. 4a squared minus 20a plus 25. Booyah! It checks out. So, just letting you know, if one strategy doesn't work, it doesn't mean all is lost. We have a lot of skills and a lot of strategies that we're developing to factor these polynomials. So, I hope you enjoyed, and I hope you found it helpful.